Okay, alright, in this video presentation, I'm going to show you how to do a sub-VI project in the LABVIEW and how to call it from a main VI. Okay, so let's start with the sub-VI first. Okay, assuming that what we are trying to do is we want to create a function that's able to perform y equals to mx plus c. Okay, so what we do is let's click on the front panel here. Okay, you give a numeric control. Okay, and also add another numeric control, and let's have an indicator. Okay. Okay, this will be your, let's say you rename this as your x input. Let's name it as x. This one will be y. Sorry, this one will be c, your constant. This one will be your output y. Okay. So in your block diagram window as well, you will have these three function here, which is x, the numeric input x, numeric input c, and also the numeric indicator y. So since we want to do y equals to mx plus c, we need to put in some mathematical operators, multiply. Okay, so x will need to be multiplied with some value. Okay, assuming that m is 2, the slope is 2. Okay, we give a constant value. So your m is 2. Okay, m, let it be 2. So you have 2x, and then plus c. So you need to have a plus operator. Put a plus, and okay, alright. Okay, so this is mx, m multiplied with x, which is 2 multiplied with x, plus with c, and you get your y. So this is a very simple function for y equals to 2x plus c. Okay, now what we need to do is that we want to make this a sub-VI. So what I'm doing here is that I'm going to select the patterns. You just right click on this part, go to patterns. Okay, so it is very obvious that this is a two input and one output. So we have 2 input here, 1 output. Okay, and what you do is that click on this and then click on this. Okay, this to assign the terminal. This one will be for this terminal. Okay, click here, this will be for y. Okay, so now we have done for this y equals to 2x plus c function. What we need to do now is just save it. Save as. Okay, I want to save it as a desktop. I will name it as sub1. Sub1. Okay, name it as sub1. So I have my sub-VI 1. Alright, now let me just create a main VI, just a new VI. Again, you will be presented with a block diagram window and a front panel window. So to do a main VI, what I need to do is that I want to call the sub-VI from my main VI. So I right click at the block diagram, go to select VI, select VI just now, and then I select the VI that have been make a sub-VI just now, so sub1. So you'll see that this is actually a VI. This function here actually encapsulates the whole sub1 into one block, and very obviously it has 3 terminals, 2 input and 1 output terminals. Okay, what I'm trying to do here is that I want to give some input to it. So let's give this okay, a pi for the C, right? Connect to this terminal. Okay. Alright, so you have a pi for C, and then let's display it in the form of a waveform. Okay, let's select a waveform because we want to see whether it can be able to generate, it can be sent to a waveform, so you can see it as a linear graph. So let's connect the output here to the waveform. Okay, then after that we can add a while loop. Let's add a while loop, so it will always keep on looping. Okay, the while loop can you can create a control for the while loop. So there will be a, once you create control, there will be a stop button. Okay. Let me just drag this thing here. Okay, so this is the stop button for the while loop. Okay, and don't forget your don't forget the input for the X. So the input for the X, I would use the iteration. So as the while loop is continue to loop, it's going to create the different iteration number here, starting with 1, 2, 3, so on and so forth. So your X value will keep on changing. Alright, X equals to 1, equals to 2, 3, until you stop the while loop. So now basically this diagram here, this is ready to be simulated. Okay, let's save it first. Let's save it as some kind of file name. Let's call it main because this is the main panel that calls the sub VI. Okay, let's save as main. Okay, since there's no errors because there's no broken arrows here, we can actually run this. Okay, let's press this run button. Let me just maximize it. Let's press the run button. Okay, you can see that there's a linear graph that keeps on appearing on the waveform chart, right? It's linear. Okay, and when you press the stop button, it will stop. Okay, right, because you are stopping the while loop. Okay, let's simulate it again. You press stop, and very obviously this is a linear line because what we are simulating is y equals to 2x plus pi, right? Just now, because the input to the C is a pi. Okay, so y equals to 2x plus pi, and the value of x is dependent on the value of I here. So for each iteration, the value of I will increase. Okay, so with this, I have shown you a very simple example on how you can call a sub VI from a main VI. Okay, the sub VI will actually represent a subroutine. If let's say we are talking about normal programmings, the C++ or Java. Okay, so a sub VI is akin to a subroutine in the textual language. So that's all, and hope that this will be able to clearly show to you the main VI and the sub VI functions.